Hello, we are going to solve some linear systems using matrix inverses. So a couple of just definitions quickly. If you see the letter I when we talk about matrices, that means it's our identity matrix. And it essentially is the same as multiplying by 1. So it doesn't ever change the value of our matrix. So what that means is if I take a matrix times the identity or the identity times the matrix, I'm still going to get that same matrix. We can have an inverse of a matrix as well, but the key is it has to be square. So it has to be 2 by 2, 3 by 3 in order for us to find an inverse. We're only going to look at 2 by 2 matrices. But if you take a matrix times its inverse, you're going to get the identity. So what that looks like is a matrix times its inverse gives you the identity, and vice versa. The inverse times a matrix also gives you the identity. So in those two cases, it is commutative. So using that information, we're going to test whether P and Q are inverses, which means if I take P times Q, I should get the identity. And if I take Q times P, I should get the identity. So here, P times Q, when I multiply, and you guys can go and check my work, but when I multiply, I get 1, 0, 0, 1. And that is what we call our identity matrix, okay? Because we have 1s on our main diagonal and 0 everywhere else. So now we have to do Q times P. When I do Q times P, I also get 1, 0, 0, 1, which is that identity matrix. Because both PQ and QP give the identity matrix, we know that P and Q are inverses of one another. If you had multiplied even in your first time and gotten like a 7 here, you can stop right there because the only way for them to be inverses is if we get the identity. And if that's anything other than a 1, you can stop. Likewise, say you got a 1 and then you came over here and it was a -4. Again, you can stop because in order to be inverses, this must be a 0. So knowing that, I want you guys to tell me, are R and S inverses of one another? Okay, so I'm going to teach you, instead of having to multiply every time to see if they're inverses, I'm just going to show you how to find the inverse of a 2 by 2 matrix. So here we have A being our matrix. We have to first verify that our determinant, so AD minus BC, is not 0. If it's not 0, we can find the inverse by taking 1 over my determinant times the matrix where I switch my main diagonal. So I switch my A and my D, and then I negate the other diagonal. So if T is my matrix, 3, -1, 4, and 2, I want to find the inverse. Well, first I have to make sure my determinant's not 0. So 6 minus -4 would give me a determinant of 10. So we're good. So we're going to find the determinant. 1 over 6, like I said, minus -4, that would turn into a plus. Here I have to switch that my main diagonal, so that's why the 2 and the 3 switched. And then negate both of these. So -1 turns to positive, and then negate 4 to give you -4. We actually have to simplify though. So 6 plus 4 gives us 10. And now I'm going to multiply 1 over 10 times each of these 4 spots in my matrix. So 2 times 1/10 would be 2 over 10, -4 over 10, 1 over 10, and 3 over 10. The last step would be to simplify if possible. 2 over 10 and -4 over 10 can simplify to 1/5 and -2/5 respectively. So this would be T inverse. We're going to utilize that inverse to help us solve equations. So if we have the equation AX equals B and all AX and B are matrices, our goal is to solve for X. Well, the only way to cancel off that A would be to multiply by the inverse because we don't divide matrices. We only multiply in this case. So we have to figure out what is that inverse of A, and then I need to multiply it on the left side. Since matrix multiplication is not commutative, when I multiply that A inverse on the left side, I also have to multiply it on the left side of B. A inverse times A, we talked about at the very beginning, would give us the identity. And since the identity is multiplying by 1, we get x to equal A inverse times B. So I'm going to model this in an example. Here's our equation. We have this matrix times x equals this second matrix. Well, I'm going to just label for simplicity so you can reference our previous rules. This first matrix is A and the second one is B. So my first goal is to find the inverse of A. Well, I have to find my determinant, so 36 minus 35. Flip those main diagonals, negate the other diagonal. 36 minus 35 is 1, so we got really lucky. This multiplying by 1 doesn't change, so 3, negative 7, negative 5, and 12 is our A inverse. So I'm going to, we found our A inverse. Now I have to multiply that on the left side of both sides of my equation. So I come back here, maybe, and I take this inverse and multiply it on the left side of A and on the left side of B. The goal in multiplying by the matrix, or by the inverse, is because these two will cancel off to my identity, which leaves us with x on the left side. And now I just have to multiply these like two regular matrices. So I'd get 6 minus 21, negative 3 minus 14, and so on. Here is what my x value would, or my x matrix would be after you simplify all of these. So x is negative 15, negative 17, 26, and 29.